Lesson 13, substitution and area of an isosceles triangle. All right, when we talk about the substitution method, this is a way to solve for two variables in a linear equation. When solving for variables in an equation, keep in mind the number of variables equals the number of equations. For example, in the example given on the board, x equals y plus 5 and 3x plus 2y equals 5. You'll notice that there are two unknowns. Okay, there is an x value and there's a y value. Now, with those two unknowns also comes two equations. So the number of unknowns is also represented by the number of equations. When solving for the substitution method, we are substituting a numerical value in for a variable and using that information to solve for the other unknown variable. All right, so we're gonna go through some steps, but we're also gonna work through this example at the same time. All right, so steps in solving for substitution. Step 1, get one of the variables by itself, or solve for one of the variables. It doesn't matter which one you choose. It can be x or y or whatever variables are in the equation, but you want to solve for one of the given variables. In our equation, for example, the first one is already solved for. X is already by itself on one side of the equation, so that's done. We don't have to worry about it. Step 1 is already taken care of for us in this particular example. All right, so moving on to step 2. Once we've solved for one of the given variables, we want to substitute the value of that variable in for the variable in the second equation. All right, so we're going to substitute the value into the second equation. All right, so x's value is y plus 5. So in place of x in our second equation, we're going to substitute in y plus 5. So we have 3 times y plus 5 plus 2y equals 5. Okay, now notice if we have one equation, we have one variable, one unknown in that equation, and so step 3 is to solve for the unknown. Okay, so we're going to first solve by distributing. When we distribute, we have 3y plus 15 plus 2y equals 5. We'll combine like terms. 3y and 2y is 5y. So we have 5y plus 15 equals 5. We want to get the variable term by itself, so we're going to subtract 15. We now have 5y equals negative 10. And then we solve by division. Y equals negative 2. Right? So we have solved for our unknown. Step 4, you're going to substitute that solution into the first equation. In this case, to solve for x. So now that we have y equals 2, we're going to come back to our first equation, which was x equals y plus 5. And we're going to substitute negative 2 in for y. So x equals negative 2 plus 5, which means that x equals 3. Right, so we have x equals 3, y equals negative 2. And step 5, we always write our answers to these as an ordered pair. Okay, so write the solution as an ordered pair. Okay, remember when writing an ordered pair, the x value comes first, so x is equal to 3, y is equal to negative 2, and then it's the solution for our equation. All right, so we're solving for one of the variables, we're substituting that value into our second equation and solving for that unknown. Once we know the known, we're substituting that solution into the first equation to solve again for our first unknown and then writing the solution as an ordered pair. Let's do another example together. This one we have 3x minus y equals 11 and 2x plus 3y equals negative 11. The first thing we want to do is solve for one of the variables, or get one of the variables by itself. I always like to choose the variable that has no coefficients. This eliminates any prospects of fractions. So I'm going to solve for y in the first equation. If I'm solving for y, right, we're going to subtract 3x from both sides. So then we have negative y equals negative 3x plus 11. And then I'm going to divide by that negative to get y equals 3x minus 11. Okay, I've taken this equation and solved for y. Now that I've got this value for y, I'm going to plug it back in or substitute it into my second equation up here. All right, so we have 2x plus 3 times 3x minus 11 equals negative 11. All right, so I substituted 3x minus 11 in for y in my second equation. Now we can solve. We're going to solve using the distributive property. 3x times 3x is 9x. 3 times negative 11 is negative 33, and it's equal to negative 11. All right, we're going to combine like terms. 2x and 9x is 11x. If we add 33 to both sides, we get 11x equals 22. And by division, we know that x equals 2. Okay, so we have solved for x. We know what our x value is. Now I'm going to take this value and substitute it back into this equation here, which was a deviation of my first equation, in order to solve for y. All right, so y equals 3 times 2 minus 11, which is really 6 minus 11, which is negative 5. So we have x is equal to 2, y is equal to negative 5. The last thing that we need to do is write our answer or write our solution as an ordered pair. We get 2, negative 5. This last example, x plus y equals 20 and 5x plus 10y equals 150, I would like for you to try on your own. Go ahead and pause the video to complete it and hit play when you're ready to move on. We'll check it in class. All right, the next thing that we're going to talk about is area of an isosceles triangle. Now, we know that an isosceles triangle is a triangle in which two sides are the same and one side is different. We are still going to use our formula for area of a triangle, 1/2 times the base times the height. But keep in mind, to find height, okay, height is the perpendicular distance from the base to the point of the triangle or to the vertex of the triangle. There is no height in this case. So what we're going to do is we're going to bisect or split in half our triangle. All right, so we want to bisect, which means to divide something in two. We want to bisect the angle, okay? When we bisect the angle, it also means that we're bisecting the segment, or the base. All right, so we bisect, first of all. Once we bisect it, we need to use Pythagorean theorem to solve for the height. All right, so we're going to use a squared plus b squared equals c squared to solve for the height. Okay, so we bisected it, and in bisecting it, we've created now a right angle. Keep in mind that when we bisected the segment also. So we split the segment in two, which means our new base is going to be 2, because half of 4 is 2. All right, so we're using, in this particular example, the Pythagorean theorem to find side A. This is our new right triangle that has been given when we bisected the one to the right. All right, so we're going to use Pythagorean theorem to solve. We have a squared plus 2 squared equals 5 squared. All right, well, 2 squared is 4. 5 squared is 25. If I subtract, I get a squared equals 21, which means that a is square root of 21. So the height of my triangle is the square root of 21. Once the height is found, then we can plug it back into our formula. Area equals 1/2 times the base times the height. Okay, so we come back to our formula, 1/2 times the base times the height. The base is 4. We just solve for the height, it's root 21. All right, well, half of 4 is 2. And you can keep the square root of 21 as the square root of 21. So our area is going to be 2 square roots of 21. And then make sure that you label it. In this case, it's just going to be units squared. Okay, so you're still using your formula, 1/2 base times height. But in order to find the height, you need to bisect both the angle and the base. And then use the Pythagorean theorem to solve with your new right triangle that you just created by bisecting the angles in the segment. All right, I'm going to have you try this example on your own. We're going to come back and check it in class tomorrow. You're finding the area of this 3, 3, 4 triangle using your area formula and using the Pythagorean theorem to solve for the height.